Hello, everyone, and welcome to the Software Systems Analysis and Design course brought to you by Annapolis University. I am Suleiman Badur, and I will be your lecturer for today's lesson. We will start our course in week one by introducing and exploring design patterns. Furthermore, we will be learning and discussing design issues and applications, how we can solve these issues by applying design patterns. This course will extend your knowledge of object-oriented analysis and design by covering design patterns used in interactive applications. Also, this course will explain and introduce several design principles that you can use to make your software more flexible and maintainable and reusable. Finally, you will learn how to define and identify problematic software designs by referencing what is known as a catalog of code smells. And we will start our lecture today by defining the objectives. What we will do today, first, we will explain what is a design pattern. Second, we will describe the Gang of Four pattern catalog. Then we will describe the pattern language, what is it? And finally, we will review a small and quick introduction to pattern categories, which are creational, structural, and behavioral patterns. So now, what is a design pattern? In software engineering, you will often come across the same design problem many times. There are so many ways to deal with these recurring problems, but over some time, some solutions are preferred over others because these solutions are more flexible or reusable or maintainable. By definition, a design pattern is a practical proven solution to a recurring design problem. For instance, instead of solving a particular software problem by basic knowledge and object-tree into programming principles every time and asking yourself questions like what objects to use, how objects need to relate, and so on, you can use previously outlined solutions that expert developers have often used. These design solutions are not theoretical proposals of only academic interest. These solutions are actual solutions used in the software industry. For instance, design solutions, design patterns can help you to fix a tangled or structureless code. For example, think of design patterns like the way you would think of recipes in a cooking book. There are some dishes that people have experimented with and cooked over and over again. But after a while, a certain way of cooking a particular dish would be preferred because it creates the best tasting dish. Similar to design patterns, over the years, experts and developers have experimented with many different design solutions, and these design patterns outline solutions that often create the best outcome. However, it's important to note that it won't be so simple to look at a software design problem and automatically know which design pattern to use. There are many design patterns available, and sometimes one particular design pattern may seem applicable, but it may not actually be the right fit to the problem at hand. For example, using design patterns is sort of like playing a game of chess. There are many ways to win by putting your opponent in checkmate. A beginner chess player may only know the basic moves of each piece, while an expert player will look for suitable and appropriate patterns on the board. There are established and famous chess patterns. For example, the exposed king or the isolated pawn, and these are patterns that experts will look to apply while playing the game. Through experience and practice, they are better able to judge which pattern to use or to create in a particular situation to win the game. Similar to chess, beginner software developers might only know the elements of language syntax in programming software. They know elements like how to create a for loop, a method, and so on. But with more practice and experience, these software developers will write more complex code that follows common conventions. Also, these software developers can become design experts who know the design patterns to use in solving particular software design problems. Another thing to note about design patterns is that it's not just a concrete set of source code that you memorize and put in your software like Java libraries or frameworks. Design patterns are a bit more conceptual. It's knowledge that you can apply within your software to guide its structure and make it more flexible and reusable. So, why should you use design patterns? Simply because design patterns help software developers so that instead of building everything from scratch, they have a guide that will help them to solve design problems in the way experts do. For example, a beginner athlete may have the natural talent and basic knowledge of the sport they're playing, but with a coach who has several years of experience, the coach will be able to help that athlete to become better and use their talent to achieve greater things. Similar to design patterns are already proven by experts and they have gone through the hardships. You can skip the trials. They have already gone through that, and you have to go straight to create a better written software. Another advantage of design patterns is design patterns help to create a design vocabulary rather than having to explain all the details of a design solution over and over again. You can simplify the discussion by having a suitable word to describe it. For example, we have a famous and common design problem in software where you have two objects and the first object depends on the second object. If the second object changes, the first object should be notified. This is a situation that occurs often in software, and we take some time during the discussion to describe a solution involving superclasses and certain methods. Design patterns help to address these issues by giving each pattern a name and make it easier for developers to communicate. Throughout this course, you will learn many design patterns. You will learn what to look for, how to use each pattern. Design patterns are important techniques to use and learn as you build and design your software. So now it's our time to start designing like an expert. Regarding our topic regarding design patterns, we have this famous and beautiful book, which is our reference in this course, called Design Patterns, Elements of Reusable Object-Oriented Software. There are 23 patterns identified in this famous book. This book was written by authors Gamma, Helm, Johnson, and Prisitz. In this course, we will go through a selection of the most common and popular patterns, and also this book considered to be the ultimate guide to build and design your software. There are many design patterns you can find in books and online. One of the most famous books on the topic is the book that we have mentioned before. This book was written by four authors who were given the nickname The Gang of Four. The Gang of Four's book built from their experience as developers. Each author had written their own programs and graphical applications. And while doing so, they have found patterns emerging in their design solutions. As a group, they have decided to formalize these patterns into a useful reference. These patterns are organized to be readable, and they are often named to suggest their purposes. With these patterns, they have formed a catalog. We will look over this catalog during this course. A very simple example of a pattern would be defining and calling methods. This catalog contains a number of patterns and solutions with a variety of different purposes. In this lecture, we will review a small introduction to the categories of patterns, but now we will define what is a pattern language. A pattern language is a collection of patterns that are related to a certain problem space. You would need to use different pattern languages depending on the context of the problem. For example, when you are designing games, you might use a different pattern language than if you are creating accounting software. For games, you have designed words such as player, encounters, etc. These words are important in design patterns for game software, but would not be found in design patterns for accounting software. In accounting software, double entry bookkeeping is a vital design solution to reduce error and ensure formality in the transactions. Double entry bookkeeping would not be defined in the pattern language for game design. Think of pattern language like human languages. If you are trying to speak with someone who only speaks Chinese, you would choose the appropriate language to communicate with them. And also, just like you would choose the language of speaking based on your audience, you would also choose your pattern language and design patterns based on the problem space. Now it's our time to design a pattern language. Regarding the categories of the catalog, there are, as we have mentioned before, there are 23 patterns found in the catalog. We'll start with the first category, which is structural patterns. Structural patterns, they describe how objects are connected to each other and how they should work to achieve a particular design goal. For example, think of structural patterns like a food dish with a combination of flavor pairings. A flavor pairings determines which ingredients may be combined together to form a suitable relationship. Some ingredients are mixed together to the point where they are nearly ambiguous. For example, garlic, chickpeas, and hummus. Others are combined but still maintain some independence, such as a salad of mixed vegetables. Some food just pairs well with others and it's not physically combined, for example, wine and cheese. The relationships among the food are defined by the pairings. Similarly, in software, each structural pattern determines these various suitable relationships among the objects. Our second category is creational patterns. Creational patterns tackle how you handle creating new objects. They are depend on the programming language being used. There are several different patterns based upon creating and cloning objects. We will look over each pattern more in depth in the upcoming lectures. And now we will review our final category, which is behavioral patterns. These patterns focus on how objects distribute work. They describe how each object does a single cohesive function. Behavioral patterns also focus on how independent objects work towards a common goal. The Gang of Four catalog use these categories in order to organize and characterize these patterns in their book. By learning design patterns, we will be able to design software for different purposes. We will be able to design software in different ways. In this lecture, we have reviewed a small introduction to the categories of patterns. We will look more in depth. We will dive more in depth into each pattern. We have reached the end of today's lecture, week one lecture. Thank you for your attention. And this list contains the references that I have used to create these slides and material. Thank you so much for your time.